Okay, let's start the class now. So, today we are doing the class for IUPAC naming. So, this problem of IUPAC naming should not be prevailing as soon as you proceed with, organic chemistry chapters in grade 12. All right? Whether you study haloalkane haloarenes, alcohol phenol ethers, or you study aldehyde ketones, carboxylic acid, or amines, any chapter, 12th is full of organic chemistry. There should not be an issue with IUPAC. So today I'm going to tell you about the basics of all the IUPAC naming. Along with that, we'll do a lot of questions today. And in the next class, when we will meet, yeah, hi Dia, how are you? Hi Pranav, good evening. So what I was telling is that next class when we will meet same day next week. Okay, so hi Tanishka. So we will talk about common naming also, you know, because apart from IUPAC naming, you need to know a little bit of common naming also. Remember, IUPAC has no barrier. You apply for all organic compounds IUPAC naming, but common naming is restricted, okay? It's only applicable to few compounds. Too much complicated compounds, we don't use common naming, okay? However, by experience, you will get to know where you need to know both and where you need to know only IUPAC, okay? I am going to brief you both common naming as well as IUPAC naming. I'm sure you would have heard of N, ISO, SEC, TERT, BUT, right? So those terminologies when they use, that is the common naming, okay? However, let's start with general IUPAC naming, okay? So all of you give the headline IUPAC naming. Okay. Online, everyone, the board is visible to you. Okay, perfect. So guys, first of all, understand IUPAC naming has basically, three parts. First is what is the first part? That is the word root. You all know that. Okay. Word root where we see the longest carbon chain and it has to be continuous. Before word root, what do we write? Prefix. Right. My name is Vikram Singh. So we write like Mr. Vikram Singh, right? So Vikram is my main name, the word root. Before my name, word root name Vikram, I added Mr. Right? That's the prefix. Singh is my title, that's the suffix. Right, general. So after word root, what we write is suffix. Clear? Now remember, prefix is of two types. We basically have two type of prefixes. And what is that? You have a primary prefix and you have a secondary prefix. There are two types of prefixes. All right. Similarly, suffix is of also of two types. Primary suffix and secondary suffix. Clear for everyone? Got it? Okay. Now, let's understand specifically what is primary prefix and what is secondary prefix. Primary prefix is something you will use it very often. Okay? Is it clear? Primary, you are going to use it very often. Secondary, it will be, wait. The order of writing is first we write 2 degree prefix, then we write 1 degree prefix. Yeah. Okay, that's how we go. Secondary, then primary, then word root, then 1 degree suffix, then 2 degree suffix. That's how we write. I hope it's clear. Okay, so first of all, understand what is this 2 degree prefixes. Okay, so this is basically is the substituents. You can call it as branches, substituent or branches. So whatever which is not a part of the main chain, whatever is not a part of the word root, it forms substituent. Okay, Shubham, clear? Now, what is 1 degree? 1 degree is basically this 1 degree is you can say we use it for specific compounds which are cyclo, bicyclo, and spiro compounds. Basically cyclo, bicyclo, and only for these three compounds we use this prefix, 1 degree prefix. All right. And then word root is what is the word root? It is the longest, longest continuous carbon chain. That is the word root. Longest continuous carbon chain. Remember, it has to be longest. It never says need to be straight. You can't skip it while counting it, okay? Connecting the dots. Same way you have to go. Longest, continuous. All right. Online, is everyone clear till here? Okay. Now, what is the 1 degree suffix? So, 1 degree suffix is basically in, or ein. You people know this very well. When do we use in? Carbon carbon single bond, right? In, if you have at least one double bond. Ein, when do you have? Triple bond, right? And what is the 2 degree suffix is? Your 2 degree suffix is functional group. This is 2 degree suffix is functional group. Everyone, please take a note. So when you write a complete name, this is how it should be. Got it, everyone? 2 degree, 1 degree, word root, 1 degree, 2 degree. That is the order. Guys, take a note of it. Okay. Now, guys, should I continue? Should we go to the next part? Everyone done? Okay. So, guys, I'm going to tell you, first of all, word root. Okay, so all of you give the headline, word root. Let's discuss the word root in detail. For word root, it has to be a longest continuous chain, right? Now, if you have one carbon, we call it as myth. If you have two carbon, we call it as eth. Three carbon, prop. Four carbon, four is but. Five is pent. Six is seven, hept, not sept. Hept. Okay. Eight is oct. Nine is non. 10 is deck. 11 is 11 undeck. Undeck. 12 is dodeck. 12 is dodeck. What is 13? 13 is trideck. 14 tetradeck. And that's the limit. Okay? Whether you write a board exam or you write an entrance exam, you don't have to go beyond this. There are many more till 100, 500. You don't need to know. Just 14, okay? You might have learned till 10, just additional till 14 you need to, okay? That's all. So un, do, tri, tetra, and 15 is very easy to guess. pentadic, right? So, but limit it is 14, okay? 14, that's all. Online clear for everyone? Okay. Now, word root is done. Now, let me introduce you some prefixes, okay? So, some prefixes I'll tell you. So, look at the sum of the prefixes. So, first prefix we represented by R. What is R? R is a alkyl group. What is alkyl group? When you remove one hydrogen from alkane, it's alkyl. So tell me, if you have CH3, what do we call? Methyl. Similarly, if you have C2H5, what do we call? If this is a branch, ethyl. Yes. Online people also, please keep your mic, unmute your mic and participate in answering, okay? If there is no noise in your background, you can keep your mic on unmute, okay? Now, what is C3H7? Propyl. Very good. Yes, it is propyl, okay? And butyl, pentyl, and so on. Okay, however, I rarely you might come across something more than butyl, okay? So I'll write C4H9 butyl and so on. You can go on and on, okay, like that. Okay, so general formula of alkane is CnH2n plus 2. Alkyl is CnH2n plus 1. Okay, alkyl have a general formula CnH2n plus 1. You can see that, Tanvi, C carbon number is 2. So what is the double of N2, 2N? So hydrogen is double of the carbon. So if C is 2, the H is 4 plus 1, so it became 5. Got it, everyone? That's the alkyl group. Okay. Now, another prefix I will introduce you, that is called alkoxy. Have you heard of this? Alkoxy group. Okay. We represented by OR. It means it's the same R, and just the thing is, before the R, there will be a O. So, for example, I'll tell you, if you have OCS3, it's called methoxy. Okay. Sometimes in the textbook you will see they write it as OMET. And they'll ask, oh, what is OMET? It's not OMET, it's methoxy. Okay. Meth is written in short also in textbook as MET. Similarly, you have OC2H5. What is it? Yes, it's ethoxy. And in textbooks they write it as OET. Okay. And then you have O C4H9. What is it? Yeah. No, it's not propoxy. It's butoxy. Yes, it's butoxy. We write it as O BUT. But they, now students wonder what is but. It's butane. Okay. So O BUT is butoxy. Okay. Fourth one. Sorry, third one. Third is you have pH. What is this pH? We represent. Uh, we represent it like this also, or we write it like this also, C6H5. If you see this is a branch, it's called online. Anyone said some answer? Tell me what it is called. Yes, right, it's phenyl. It is phenyl. Okay. Fourth one fourth one you have OPH. So easy peasy. What do we call? If pH is phenyl, OPH will become phenol. Phenoxy, yes, not phenol. Phenol is something else. So this is phenoxy. Okay, got it, guys. Fifth one, fifth one is a branch you will see NO2. What do we call it? Nitro. Guys, got it, no? NO2 is nitro. Sixth, you have halogen groups. For example, you take, if you have Cl, we call it as chloro. If you have Br, bromo. If you have F, fluoro. And if you have iodo. Guys, please take a note of all this. Okay. Let me just uh, tell what you're saying for OME for are you talking about methoxy? See, sometimes they write OME or they write OMET. It's all methoxy, okay? Avantika, you clear now? Okay, guys, let me check if I am not missing anything. Hello, nitro, phenyl, alkoxy, everything I told. One I'm missing. What is uh what is this one, guys? Seventh one. No means no. If you have NO, then nitroso. Yes, this is nitroso. And last eighth one. What is this? See, this is nitride. This is nitride, but not this. This is nitride ion, right? You'll know what is this. It's called azido. Okay, write it down. Azido, guys. So these are your prefixes. Okay. Now, who are cyclo? So these type, I think I did not give the headline. What I introduced you is which prefix was this? 2 degree or 1 degree? It was 2 degree prefixes, right? Now let me introduce you 1 degree prefixes. So 1 degree prefix. 1 degree, I told you know it's specific to some compounds. So if you come across this kind of structure, mm, if you come across these kind of structures, cyclo, these are cyclo. I hope it's clear. And if you come across these kind of structures, okay, these compounds are bicyclo. Okay, when I take specific classes for that, then I'll explain it to you. Okay, these are these are bicyclo compounds. Okay, where you observe these kind of things. Bridgehead carbons, which is a common carbon for both rings. See, there is one ring, there's other ring, right? One ring, other ring, right? Such compounds are called bicyclo compounds. Avantika, you clear? Ananya, Tanishka, Dia, Tanuj, Dia, you have understood, right? Okay, Dia, one more thing. Tomorrow you don't have a class for biology because exams we will be keeping it from the next week, okay? Once we finish a bit, okay? Yeah. Okay, after that, guys, tell me one thing. You are clear about bicyclo, right? So in bicyclo, how do you identify bicyclo compounds? You will see there will be two rings and they will have common carbons, okay? They are called bridgehead carbons, top and bottom. Okay. See, this is also a common carbon. This carbon is also common, right? But it's not on either on the top nor on the bottom. So it's not called as bridgehead carbon. Only the top and bottom carbon of the common carbon in bicyclo are called bridgehead carbon. Okay, what do we call it? So such carbons are called bridgehead carbon. This is also a bridgehead carbon. Only top and bottom. However, when I'll teach you this topic bicyclo compounds, then only I will explain. And remember, when you know how to name the IUPAC of bridgehead carbon, then you can write the IUPAC name of a Christmas tree also. All right. So for a people, it's a Christmas tree. For you people, it will be a some organic compound. Anyways, later on we'll do that. So next we will see this last one, Spiro. So Spiro may you will see it will be something like this. Sir, what are you drawing? Kaju Katlis? Yes. Okay. For chemistry people, it's not Kaju Katlis. Okay. You know when you put two Kaju Katlis joined, right? You see Spiro. All right. Now, how do you identify, sir, why it is not bicyclo? They also have a common carbon. There are two rings. No, there is not. Because, see, how do you identify them? The both the rings are joined by a 4-degree carbon. See, this carbon is attached with four carbons. One, two, three, four. Quaternary carbon. So when you come across such compounds where two rings are joined by just one 4-degree carbon, then it's a spiro compound. Okay. This carbon is a 4-degree carbon, right? Okay, Avantika, you're clear? Advait, BHC is a in the common carbon, right? See, there are two rings, right, Avantika? So in both the rings, there are common carbons, right? Carbon which is common for both the rings, right? So the top and bottom are called as bridgehead carbons. This also is a common carbon, but it's not in either top or at the bottom. So it cannot be a bridgehead. You got it now? Yeah. Okay, understood everyone? So only for these three compounds we use primary suffix, prefix. Okay, so for these compounds we use the prefix pyro. All right, done. Word root we have studied. Now let's go to suffix. All right, let's go to suffix, guys. So in suffix, what do I tell you? You already know about aniline, right? Alkane, alkene, alkyne. You already know about it. Correct? And functional group we will discuss when it will come. Or should I tell you now only? Okay, that's a good plan. Let's discuss functional groups. Okay. So guys, give the headline. Everyone give the headline. Secondary suffix. Secondary suffix. Okay. Which are functional groups. Functional groups. Now, what are functional group? If they are present in the chain or in the ring, they largely determine all the chemical and physical properties. It means if they are attached with any chain or ring, then the entire compound behaves according to them. They actually take control over the ring. So they have the highest in priority. Remember, they have the ones who have highest in priority. they are the highest in priority over anyone. I hope it's clear. Highest in priority means they should get, they gets lowest number in the, they will get the lowest number in the chain. Means you have to do numbering in such a way that functional group should get the lowest number. Okay? I hope it's clear. Now, and what about the what about the prime any 9? They are less preferred. Oh, they are also most preferred ones, but not as compared to functional groups. Is it clear? So if you ask me, sir, what is the preference order? So what is the preference order? So remember, first preference is the branches substituents. First is substituent. If there is no functional group or anything, then substituents are preferred. That also if you have multiple substituents in alphabetical order. In which order? Alphabetical order. Substituent. After that, who is preferred more? Then who is preferred more? The double and triple bonds. Okay. Double and triple bonds are preferred. And if functional group at the end, they have the highest priority. Guys, write it down. So that is the priority order. When there is no double and triple bond and there is no functional group, then alphabetical substituents. If there is no functional group, double and triple bonds are preferred. Now you might ask me a question, sir, what if there is a double bond also and triple bond also? Then who is preferred? No. So guys, write it down. A note point. Double and triple bonds have same preference, have same priority. But in case of tie, in case of tie, double bond is more preferred. Please take a note of this. So they both have equal preference. Got it, no? But in case of a tie, equal preference means what you people have understood. What do you mean by equal preference? Tell me. Equal preference means, let's say there's a compound. The double bond is here, but the triple bond, triple bond is here, but the double bond is here. Okay, got it? So understand. Oh wait, I made both. Now it's fine. Yeah. So first of all, if I check the double bond position, it's coming at number carbon number 2. But if I see the triple bond, it's coming at number 1. So it's not like double bond will have more preference. Whichever is at the lowest number, we will start counting from there. So actual number will be like this. Got it now? But in case, but in case the double bond, triple bond is here and double bond is here. There is a tie. Both are at first position. So the numbering will start, in that case, the numbering will start not from here, but from here. Clear? Understood everyone? So generally double and triple bond have same preference, but in case of a tie, we prefer the double bond. Okay? Is everyone clear? Guys, please confirm. Double bond is preferred. Yes, yes, you are right. Got it, no? Okay. Okay. So we have done enough. Let's learn by doing questions now. Okay. We have learned some basics, right? It's time to apply. So, guys, let's do some questions. So, before I give you questions, whatever you have written so far, okay, take 1 minute of time and go through it. Just 1 minute. Everyone, please quickly recall everything what we have done for a minute, just for a minute. So, guys, I'm going to give you a question now. So, let's start with the first question. Yep, first let's start with the easy one. So, guys, what do you see? It's a swastik symbol, right? Now, write the IUPAC name of this. Choose the longest chain, everyone. Stick to the basics. You need to select the longest chain. And let me know who wants to tell the first answer. Shubham, you go to school, which school? Which school? Okay, Sriram Global, right? Yes, Avantika, give your answer. Okay, yeah, I'm expecting more answers if you have. Guys, choose the longest. Okay, one, two, three, four, five, six, seven. See, all sides are same. So the longest chain is seven, right? And at fourth carbon, if you see, there is three carbon branch, right, Tanvi? So this is the branch, right? This is also the branch because they are not a part of the main chain. You have not counted them. So three branch means propyl. Fourth position it is present. So two of them are present. So 4 comma 4. You have to indicate the position of all branches, even if they are same. And because same are there, we will use the word di, tri, tetra, correct? So the answer is 4 comma 4 dipropyl heparin. Advitya, you got it, no? You understood this? All right. Now, so guys, let's try the next one. 1, 2, 3. No, it's not possible. Guys, tell me the answer for this. Remember, at every intersection there is a carbon. At every point there is a carbon. So, Antika, in case if you get it, please keep the answer with you. I need someone else to answer this time. You can match. What does the F indicates? I told you, no, fluorine. Tanishka, you got it, no? Fluorine, yes. Dia, do you have any doubt till here? Hey, wait, let me write it down. Yes, Ritvik, now you tell. Slowly. 1,5 die. Die in. In you said first. In is a suffix. In should come later, no? First you write prefix, then word root, then suffix. Yes, Tanishka, you want to give the answer? Wait, let me check the answer for this. Yes, Tanishka, give the answer. 2 ethyl. Wait, ethyl. Where you got ethyl? This one are you talking about? Okay. Okay, 2 ethyl after that. 2 comma 4 difluoro. 1 comma 5 diene. But where is the word root? Tanishka, word 1 comma 5 hexadiene. That's what you meant. Hex, yeah, hex 1 comma 5 diene. Okay. Avantika, is this your answer? Did you get this? Okay, let's check it out. So, guys, no any doubt, the first carbon will be this. This is our first carbon, right? First, second, third, fourth, fifth, sixth. If we have something like this, okay, Aditya, what was your answer? Same answer you got. Ha. So, Tanishka, if you see, you have missed methyl. This is a methyl here, right? Tanishka, you have missed a methyl. Rest everything is correct. So, let's answer this now, full-fledged answer, okay? The answer is, in this case, alphabetically you will go first. So E for ethyl, then A, B, C, D, E, F, then F, and then M. So first of all, 2 ethyl, and then you have 4, 2 comma 4 difluoro, 2 comma 4 difluoro, and after difluoro, what is there? 4 methyl, hex, 1 comma, how much? 5 diene. This is the final answer. Okay. Okay. Surya, Prem, you got it, no? Okay, good. Advait, you're clear. Pranav, Yeah, A, B, C, D, E. Yeah. Remember, by, try, die, we don't use them in alphabetical orders. We only use them to indicate how many branches are there, right? Or double bonds are there, or functional groups are there, whatever. Same. Got it, no? And Dia, did you get this? Okay. So, guys, let's try this one. How will you solve this third one? So, for this question, you have, yeah, tell me what is the answer for this one, for third question. Wait, I'm writing one question more. Guys, solve the fourth one also. Yes, Ritvik, you're telling you're trying for the third one. Go ahead. Yes. 6 ethyl, 5 methyl. How many? Dec. Dec 2 in. How many people got agree with this answer? Oh, yes. My bad. No, it's not a Cl first of all. That's mistake. Let me rectify. It's double bond CH2. Is it clear now? Yeah, it's a double bond CH2. Yeah, my bad. Okay. So let me verify this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the answer will be 6 ethyl, that's right. And 5 methyl is also right. Then you have deck 2 in. Yeah, it's a correct answer. Good, Ritvik. Good job. Guys, solve the fourth one now. Then I'm ready with another question. Guys, let's do this one now. Guys, this year board exam, people who wrote the board exam, their results are not out yet. But obviously, we are expecting some superb results. But last year, 7 people got 100 out of 100 in chemistry. Okay, from here, I taught them. And this year also, we are expecting something like that performance. But this year, okay, I am expecting more, more than 7 people to come up and get. 100 out of 100 in board exam. Okay, so keep the motivation high and remember you are not letting anything pile up. Frequent revision, more practice, that's all, you're sorted. Chemistry is not going to be a burden. Okay, you have to worry about physics and maths more. आकाश को आईआईटी जेई पे चाहिए लिंक देना ऑनलाइन yep fourth one yes Ritvik you have answered one question you will not answer you will match oh, you're asking a doubt okay tell me what is the doubt here I told you know double and triple bond have equal priority but in case of a tie then you prefer the double bond. See, did you get the longest chain first of all? See, if you are getting a longest chain, I am very sure you all are getting this as the longest chain, right? No, wait, my bad. We can't leave the double bond. Yeah, it has to be a longest chain, right? We can't miss the double bond, okay? So, well, in that case, triple bond is coming at second position, but double bond is at first. So, without any doubt, we'll start the numbering from double bond. So, your numbering will be 1, 2, 3, 4, 5. Oh, acha, acha. You people are confused whether we write in first or ein. Right. Yeah. So always remember in then ein. Okay. E and then Y. Okay. Got it? No. E and Y. Okay. No, the thing is the priority is for the selecting the lowest number. But when you are writing, both are double and triple bond. They both are the suffix, right? 1 degree suffix. So when you write suffix, you write E and Y. Ha, E and Y first, okay? So guys, who is going to tell me the final answer? Dia, will you try? Advitya, Tanvi, guys, okay. You want to try? Okay, give the answer. Tell me what is the answer you're getting. 2 ethyl, 3 methyl. After that, hex 1 in or in, it's fine. Yes, it's a perfect answer, okay? So everyone, please write down the answer. Okay, first of all, let me check with everyone. Did you all understood why did we do the naming like this? Because we should not miss in search of in search of the longest chain. See, we were getting in search of longest chain, you should not skip out double and triple bond. Your try attempt should be with the longest chain, you have to get the double and triple bond also. Okay, and remember when there was a tie, we prefer the double bond. So the answer is this is a substituent, this is a substituent. So 2 ethyl, 3 methyl, and then you have hex. After that, hex, in, hex 1 in, hex 1 in, and after that 4, 4 in. Now you might ask me one more question here. Sir, why you have not written ENE in? Why you wrote just ENN? Because there is a rule. Yes. Guys, take a note of it. A-E-I-O-U. A-E-I-O-U and Y. They are taken note of it. When these vowels, even Y also, IUPSC identifies Y also as a vowel, okay? So when these vowels, they are in continuous. When two vowels are continuous, ignore the first one. Ignore the, Diya, you're clear? So that is why E and E in for in. Can you see, Diya, that E and Y is repeating? Do you see this? Hmm? So we ignored it the first one. Are you clear now? So take a note of this rule. And everyone solve the next question, that is draw the structure of dimethyl butane. Whenever such questions comes, remember focus on the word root, draw the skeleton and accordingly you put positions. Focus on word root, but. There should be a 4 carbon. Now you wonder what you have to do. Okay? Yeah. Finish it quick. It's a very easy question. Okay? Now let's do some tough nuts. Okay? So hope everyone has got this. So Tanvi, how will you draw? But means 4 carbon you'll draw, right? Now it says there is a ion. So it means one carbon, first carbon has a triple bond. Then what it says 3 comma 3. So 1, 2. So third carbon has 2 methyl. Done. So this is the answer. Simple. Okay. Aditya, clear? Okay. Good job. Okay. Now I'm going to give you some different type of compounds, and we will also discuss how do we write the name. So guys, focus on this compound now. Another question. Now my question is, how will you write the name for this? Guys, please see this. Complex substituents. The problem here is that the center carbon is connected. So how do you identify that we have a complex substituent? Let me show it to you. So how do we spot there is a complex substituent? So if you see, this is the main chain. Guys, tell me. Correct? This is the main chain, this is the branch. Now if you see, that catch is the branch also has another branch. Right? Shubham, ये पता चल रहा है? The branch has another branch. ये देखो. So such cases, it's called complex substituents. All right. This is the main chain. This has another branch and the branch has another branch. Yes, Advitya. Hmm. This and this. This is the main chain because it has the longest carbon, right? Ha! You can take it like this and then it's six carbon chain. You are telling that same question can be written in different way. No, I'm talk. See what you are trying to do. You are telling this branch can be here or something. Can you come? It's fine. You can come. And you can do one thing. I'll give you a space. You can redraw whatever you feel like. Yep. Yes, you can draw, no? There's no problem. Acha, acha, I understood. What you are telling is this is your main chain. Wait, I'll change the color now. There's so many colors. You are telling this can be one chain, right? No, no. Thing is, see, Aditya, when you are having this as the longest chain, right? Then you have a methyl and ethyl, correct? Now I'll tell you what problem is coming here, okay? Wait, let me rewrite this. One, two, three, four, five, six. Huh. Do you see that? And now, hmm. So in this case, if I select this as a main chain, as a longest chain, right? One, two, three, four, five, six. Okay. See, in this case, what will happen? First of all, please see, it will be 2-methyl, 3-ethyl, and hexane, right? Correct? Is everyone getting it? Yeah. So understand whenever you have such scenarios and you are able to write the IUPAC name without forming a complex substituents, right? Then you are going to prefer that, okay? Yes. So Aditya, your answer is right. We will not prefer the complex naming them in that case. All right. Got it, no? In order to make this as a, one second. So all of you, please take a note of this. If you are avoiding a complex substituent, okay, and if you are writing a IUPAC name without complex, then this will be a correct approach. Okay. Now let me give you a question where only and only complex substituent possibility is there, no other possibility. Okay. So I'll give you another question. So remember, we will not prefer this one. Okay. One sec. Okay, everything will go away. So let it be. Let it be as example. Okay. Yes. Is everyone understood, guys? So if you can if you can ignore the complex naming, right? Okay, then you can do it. Okay. Understood, everyone? Because IUPAC naming rule says that if you have multiple ways to number the carbon chain, then you should prefer the one which gives you more branches. Here we are getting two branches. Here you have only one branch, right? That is why this is more preferred. I hope it's clear. Everyone understood this? Kindly confirm. Okay, but now let me give you a question where there is no possibility of other option. Hmm. Yeah, say it again. What are you telling? Hmm. No, that's what. See, this whole thing is considered as one branch. You're getting my point, Avantika? So here you have two branches. Here you have one branch versus two branch. So that is why this is preferred. But I understood your question. What you're telling is, suppose if in this case also if there is only one branch, here also there is only one branch, then which one is preferred? So complex is always least preferred. Avantika, are you clear? Okay. Now let me give you an example of complex substituent where you have no other possibilities. Okay. So guys, let's take an example. Okay, and you have, okay, see, in this case, if I come up like this, in this case, if I come up like this, what is happening? We are not getting the longest chain, only six. So we have no other option, but we have to choose this as a longest chain. Now, this is the perfect example. So you can see that. So the branch has another branch, and that has the another branch. Okay. Dia, you're getting it? We have no choice. We have to choose this as the longest chain. So you can see now this is a branch, and that branch also has another branch. See, if this carbon was here, if the bonding was here, we could have easily made three propyl, right? A four propyl and heptane. But the problem is the center carbon is attached. So what's the rule? Rule is very normal. You do the normal numbering, okay? In such a way, the branch gets the lowest number. So 1, 2, 3, 4, 1, 2, or in both sides, you are getting 4. Done with the numbering of main chain. Now the rule says you give a 1 dash number. The rule says you give a 1 dash number. Why dash? Because already there is number 1. So there should not be a confusion. So rule says, write down the rule, give 1 dash number to the carbon, to the carbon atom directly attached, directly attached to the main chain. Got it? So we will give this as a 1 dash. Please see, here we will put 1 dash. Then it says, then the second point says, write the branch name, write the substituent's name, write the substituent's name and end with YL. Okay, write the substituent name and end with YL enclosed in brackets. Enclosed in brackets. So guys, now can we tell the name? Okay, did everyone understood this rule? Tanuj, you got it? Advait, Surya, all right. So what we will do, at which position the branch is present? Fourth. So you'll write 4, open the bracket. Now if this is 1 dash, what is the longest chain in the branch? 2 dash. Now this carbon is attached to 1 dash carbon, right? So how do we write? 1 dash methyl and it is ethane, right? But rule says end with YL. So ethyl. Yes. Close the bracket. What is the name? Heptane. Done. This is the answer. No, see, understand. This is the branch and ये है branch का branch, right? They are not on the same line. They are not on the same level. You're getting my point? So that is why this is present at 1 dash, right, carbon, this branch. So that is why it's 1 dash methyl first. And then this ethyl. You got it, no? यहाँ पे alphabetical नहीं लगेगा. Because they are not on the same level, right? Shubham, you're clear, right? Hmm? Okay, for online, Pranav, Ananya, is everyone clear? Diya, did you get it? Last part I said the name should be written in the bracket and you are ending the name. Say, Kanishka, what is the name of this part? It's methyl ethyl, right? one methyl and then ethyl. That is the name we have added here as a branch name. Methyl and ethyl. Because rule says ending should happen with YL. So we have not written methyl ethane. We have written methyl ethyl. Got it now? Diya and Tanuj, can you guys confirm? Okay, so try yourself. I'll give you another question now. Guys, solve this. Wait, first of all, one, two, three, four, five, six, seven, eight. From that side also it's five? Okay. Okay, so you'll prefer this side, right? Okay. So this has to be one dash. This is two dash. This is three dash. So they all are branches. This is a branch. This is also a branch. Right. So what's the answer, guys? So first of all, you have to write number five. It's present at fifth position, right? First of all, five, then open the bracket, then one dash. Yes, Tanishka. Yeah, one dash ethyl, then methyl, and then propyl. Right? Then propyl. First of all, online everyone confirmed. Did you all understood how I wrote this name in this sequence? See, the rule says the one dash will be given to that carbon which is directly attached to the main chain, right? So if this is one, then the longest chain rule apply here also. So one, two, three. So this one dash position has two branches, methyl and ethyl. So here alphabetical order will apply. You got it? No, because for this one dash, they both are the branches. Yeah, you don't need to write one dash. You can ignore also. IUPAC. Yes. Understand, for the same level, same rule applies. Okay. But for branch, you can't compare with its branch. You're getting my point what I'm saying? Okay. Alphabetical order applies on the same. So if any other branch will come, say suppose any branch is here, then there would be a difference in this branch and this branch. They are on same level. Got it? No. Similarly, this one dash has two branches. So that is why we wrote ethyl first, then methyl, and then the whole name, propyl. I hope it's clear. Propyl actually was the. Yes, Avantika. Again, tell me what modification I should do. Three methyl. Oh, acha, your doubt is if there is a methyl group at third position, then who do I write first? Okay, let me tell you. Well, in that case, if third position has a methyl group, so understand M for methyl, right? But here E for ethyl is coming first, right? So this complex naming should be written first, and after you that you write methyl. Is it clear? Understand if it's very clear. Here it starts with E, here that it starts with M. So that is why E will be written first. Then after methyl means in dictionary where it will get over. You need to check methyl is a tie, but after that you got it, no? So after that, if someone has A also, then the one which is only methyl is preferred. Okay, you got it, no? It's simple dictionary calculation. Okay, Avantika, you're clear? Okay, yeah, another complex you're telling. In 2 dash, if I add another methyl here, that's what you're telling. Okay, let's assume there is another, substituent is there. Well, in that case, what you will do for this 1 dash, you have written about two branches. Right. Then after that, you will put 2 dash and you will write its branch. And then you will write profile. Understood, no? Yeah. If 2 dash has a methyl, if 2 dash has a dimethyl, is it clear? Then how will you write understand? For 1 dash, you will write ethyl first. Got it, no? And then for methyl, you will write it as 1, 2. Yeah, Tanishka. So you will write it as dimethyl only to 1 comma 2. 1 dash comma 2 dash dimethyl. General IUPAC naming you have to give. Is it clear? For branches also, complex substituents, you have to give general IUPAC naming. I hope it's clear now. Okay, so now let's check finally how much you have all understood. Okay, so I'll give you the most difficult question in complex naming, which has came in the entrance exam. So let's try that. So first of all, let's write the question CH3, CH2, CH2, CH, CH, C, CH2, CH3, CH2, CH3, CH2, CH3, CH3, and CH, CH3, CH3. Guys, solve this. Uh, yep. Guys, solve this now. Everyone give it a try. See what you're getting. No, 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 no. That is not the start. Good try. Manishka, try again. Come up with the answer. Hmm. Yeah, yeah, carry on, Aditya. Ah. Yes, that's the right answer. Very good. Okay, so guys, see how do we solve this? Everyone pay attention. How do we do this? Longest chain. Okay, focus on getting the longest chain. So can we say how do we get our longest chain? 1, 2, 3, 1, 2, 3. Okay. So you can just select one longest chain. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Because if I come down 6 and 7 only I'll stop. Maximum 8 is possible, right? Now this you can see is a 1 dash, so it's a 2 dash, right? Now, moreover, how many branches are there? This is one branch, this is another branch, this is another branch, and this whole thing is another branch. So many branches are there. This is how you identify the branches after selecting the longest carbon chain. Okay? Tanuj, you got it now? Yeah. Who has a doubt? Tell me. No, no, no. The problem is, Ananya, you have raised a very good point. What you are telling is this should be number one, number two, number three, number four, like that, right? Now, the problem is we are not trying to give complex substituent as the lowest number. What we are trying to give is the lowest sum rule, where maximum branch should be in the lowest number. Okay, Ananya? So if I start from there, all branches go at very. We never try to give complex. See, complex substituent and any other branch is just like a same level we compare. You got my point. There's no special rule for that complex substituent. So what I'm trying to tell, when I give the numbering like this, understand Ananya, the two ethyl came at 3 and 3. So what is my positions? Tell me, Ananya. Ethyls are at 3 and 3, methyl is at 4, right? And this is at 5. So what is the number I'm getting? 3, 3, 4, 5. Ananya, you got it, no? But if I go from that number, what are the numbers I'm getting? Four, first substituents are coming at 4. Then you have at, 4 के बाद you will have 5 and then you have 6, 6. Now, if you see first number, it's 3, first number is 4. That is why this is preferred. Lowest sum rule. Is it clear? In case of multiple substituents. So you raised a very good question because that is a very common doubt for a lot of students. Okay. So guys, now finally coming to the answer, alphabetical order, all are the substituents. So alphabetical order, ethyl is preferred here. So 3 comma 3 diethyl and then 4 methyl, very good. Finally, you will have 5, open the bracket, 1 dash, methyl, ethyl, ending should be with YL, and finally after that, octane. So that is the final answer for this question. Okay, I hope it is clear to everyone. Hmm. Where ethyl, methyl? No, 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 no. It will be methyl ethyl because this 1 dash and 2 dash. This is the देखो ये ब्रांच का ब्रांच है, इट्स अ सब्स्टिट्यूएंट, यू गेटिंग माय पॉइंट? दे बोथ आर नॉट ऑन द सेम लेवल. This is the branch ka branch and this is the branch of this branch. You got it? So here alphabetical rule can't apply. You got it now? It is something like this is the grandfather, this is the father, and this is the son. Three generations are there. So you can't go alphabetically in three different generations. Understood now? Clear now? All right, perfect. So guys, make sure that you keep practicing. I'm going to give you some worksheets for the IUPAC name. Tomorrow you will receive the worksheets on IUPAC naming practice. And next time when we'll meet on IUPAC naming, we will talk about functional groups and we will talk about some cyclocompounds, you know. All right. And after that, I'm going to tell you about the common naming. All right. You have to be a legend in IUPAC in next 1 or 2 months. I would say in next 1 month. Then only your organic chemistry will be easier. All right. Bye, guys. Yep. Yeah. Thank you, everyone. Bye. Thank you, guys. Bye.